All right, so we've talked about how there are certain rules for alternate interior angles and alternate exterior angles and parallel lines and transversals that cut them and all those things. And so now, and we talked a little bit about what happens when those two lines are parallel with the transversal. The special relationships happen. For example, your corresponding angles. Okay, that's its corresponding angles postulate here. If there's two parallel lines cut by a transversal, then the pairs of corresponding angles are congruent. All right, and then the alternate interior angles theorem, they're also congruent. It's not until you get to the same side interior angles theorem where they're no longer congruent, but they're supplementary, and uh, and and we'll go on like and the rules go on so on and so forth. Okay, so so today now though we're going to practice proving that these things are true. All right, so I just drew a proof and I lost it, and here it is. You should be able to see this proof now. And so, oh geez, what was I talking about? Oh yeah. So in trying to prove this thing now, so we've got these lines here: line L, line M, line P, and line R. And the only thing we know right now is that line L is parallel to line M, and we see that in the statement they give us, and in these little pink arrows that are here. We also know that angle 1 is congruent to angle 3 because they told us that as well. But what we're going to try to prove is that line R is parallel to line P. That we can't assume. They may look like they are, but we can't say they are just because they look like it. And so we're going to have to use some geometry to go about proving that. So the first thing we know is that L is parallel to M. Okay, it's the first thing we know. So we're going to write that down and say that's given. Now, what can we say because line L is parallel to line M? Well, then we can say that angle 1 must be congruent to angle 2. And what's the reason that we can say that? And pause the video for a second if you need to. Take a look at your theorems and notes from the oh goodness, from the Quizlet that I gave you. And what's the relationship of angles 1 and 2? Are they alternate interior or exterior, or same side interior or exterior, or are they corresponding? Like, what are they? And if you pause the video, you'll notice that these are corresponding angles 1 and 2. And so corresponding angles have this theorem for them that says that if two parallel lines are cut by a transversal, and P is the transversal in this case, then the corresponding angles are congruent. So we're just going to say, so what's the reason? The reason is the corresponding angles postulate. All right, that's why angles 1 and angle 2 are congruent. I'll even throw my symbols in there. Boom, boom. Those are the same. Those angles are equal to each other. So what else? What else do I know? Well, I also know, according to the information, that angle 1 is congruent to angle 3, right? And how do we know that? Well, how do we know that? Well, that's a given. So that's not impressive. That's a given. Okay. But now that we know that's the case, and I'm going to switch colors up now. But now that we know that's the case, what's the next thing we can say since angle 1 is congruent to angle 3? Well, we can't forget our other postulates and theorems and other definitions that we've learned and properties that we've learned. If angle 1 is congruent to angle 2 and angle 1 is also congruent to angle 3, then we can say that angle 2 is congruent to angle 3. That's the only matchup we haven't made yet. And why is that? Well, that's that transitive property. That's a transitive property. Oops, I forgot that. Transitive property of, now this is of congruence, not equality, of congruence, because I mean it's obvious because it says congruent. Okay, transitive property of congruence. So if angle 2 and angle 3 are congruent, then we can say that R must be parallel to P. And you're like, wait a minute, how? Why? Well, if angle 2 is congruent to angle 3, then look at the relationship of these two angles. They're on different sides of the transversal, and they are congruent. So that means that through the we would call this alternate exterior angles. Is that theorem or postulate? Theorem. All about a theorem. Okay, so we're basically saying it goes both ways. We're saying if you have two parallel lines cut by transversal, then their alternate exterior angles are congruent. Or you could say it the other way around, which we call that the converse. If there are two angles that are congruent, if there are two lines cut by a transversal and their alternate exterior angles are congruent, then those two lines are parallel. All right, and so we're going to stop right there because that proof is done.